In this video, I'm going to be covering grade 11 financial maths. So I'm going to kind of just jam pack it full of everything that we kind of do in grade 11 so that it's all in one video. I'm not really going to be discussing simple and compound interest because that we've been doing since we're in grade 8. What I am going to be doing in this video is I'm going to be doing depreciation. I'm going to be doing timelines. I'm going to be doing nominal and effective interest rates. So all of that I'm going to be doing in this video. If we get straight into depreciation, depreciation is broken into two types of depreciation. We have straight line depreciation and we have reducing balance depreciation. Now, straight line depreciation is depreciation using the simple interest formula, except instead of a plus sign, we're going to put a minus. And then we have reducing balance depreciation, which is our compound interest formula, except without a plus and a minus. If we look at the first question, we have a machine costs 25,000 Rand in 2016. So that's important. Calculate the book value of the machine after 4 years if it depreciates at 9% per annum according to the reducing balance method. Whether we're talking about simple interest, compound interest, straight line depreciation, reducing balance depreciation, we are talking about the A, the P, the I, and the N. So those letters kind of stay the same in all of those formulas. So I just want to quickly talk about what each letter stands for and also different ways that we could talk about the letters, because I think that that's pretty important. So if we're talking about the A value is the accumulated amount. Now we could talk about it as accumulated, we could talk about it as end amount, future amount, total amount, anything to do with future tense. That's the A value. P value is the present amount, the principal amount, or the past amount, the amount that it was. The I is my interest rate divided by 100. So it's not the interest rate. The interest rate is a percentage and the interest rate is out of 100, right? However, the I value is your R over 100. So it's your interest rate divided by 100. And then your N is your number of years. So the machine costs 25,000 in 2016. Calculate the book value after 4 years. So we've got A, P, I, and N. All right. So we want to know the price or the book value after 4 years. So we are looking for the after amount, the future amount, the A value. The machine costs 25,000 when we start. My interest rate is 9%. So my I value is 9% divided by 100, which is 0.09, and it's for 4 years. All right, so it says the reducing balance method, which means that I'm going to use my compound interest formula except with the minus. So A is equal to P into 1 minus I raised to the power of N. So A is equal to P, which is 25,000, into 1 minus 0.09 raised to the power of N, which is 4. So therefore, A is equal to, remember with money you need a unit and 2 decimal places. So when we type that all into our calculator, we get an answer of 17,143 Rand and 74 cents. If we quickly talk about the difference between nominal and effective interest rates. A nominal interest rate is the interest rate that you're quoted in the question, whereas an effective interest rate is the equivalent interest rate that you'll have earned or be charged once your compounding has been taken into account. Remember that your effective interest rate will always be marginally higher than the nominal interest rate. So effective interest rate will be a little bit bigger than your nominal interest rate. We have the formula to convert between nominal and effective interest rates. So we have our effective interest rates and we have our nominal interest rates, and then we have an M. And the M is the number of times a year the nominal interest rate is compounded. So if it's compounded annually, the M will be a 1. If it's compounded monthly, the M will be a 12. If it's compounded quarterly, the M would be a 4. If it's compounded daily, the M would be a 365. So the M is the number of times a year the nominal interest rate is compounded. So the question says the nominal interest rate of an investment is 12.35% per annum compounded monthly. Calculate the effective interest rate. So now we have the nominal interest rate is 12.35%. We have that it is compounded monthly, and they want us to calculate the effective interest rate. So I have the compounding period, which is monthly, so my M is going to be my 12, and I have my nominal interest rate, so I am going to substitute my nominal interest rate in place of nominal, and then I'll be able to calculate the effective interest rate. So 1 plus the effective interest rate is equal to 1 plus the nominal interest rate. Now it's an I value, right? So it's not an R, it's not the interest rate, it's the I value, which means that I still have to divide it by 100. So 12.35 will become 0.1235. And that will be over the compounding period, or the number of times it's compounded, which is 12 raised to the power of 12. So that means that the effective interest rate, I can take this 1 and I can take it across the equal sign and I can subtract it from the other side. So that means that this would be equal to 1 plus 0.1235 over 12 raised to the power of 12 and then minus the 1. Now I'll be able to put that into my calculator, and that will give me the I value of 0.1307360773. All right, so now I have an I value, and I would be able to round this I value off to 4 decimal places because then I'm going to convert it. But it's asking for the interest rate, and a rate is out of 100, so that means that I'm going to multiply by 100. So therefore the interest rate will be equal to 13.07%. Now you can see that the nominal interest rate was 12.35 and the effective interest rate is 13.07, and 13.07 is bigger or higher than the 12.35 because the effective interest rate is higher, greater, bigger than the nominal interest rates. For the next question, it says the value of a property increased from 140,000 to 221,292 Rand and 32 cents over 6 years. Calculate the average annual rate of increase of the property over the 6 years. We are going to be working with interest rates, but we need to know how to calculate an interest rate. Now, to determine an interest rate, remember when you have your formula, you have 4 letters. You have an A, a P, an I, and an N, which means that you can calculate any of those 4 provided you have the other 3. So you don't always have to be calculating A. You could be calculating P, I, or N, depending on what you're given and what you need. So no matter what you're calculating, we're just going to manipulate our formula in order to isolate whichever variable we're looking for. Now, the change between effective and nominal interest rate, that change is the specific formula that we just did in the previous question. So that one you need to know off by heart. Whereas this question, we're just calculating the interest rate based on our compound interest, all right? So that means that we don't need to know the formula off by heart for effective to nominal because we're not converting between effective and nominal. We are calculating an interest rate. So this is compound interest because it's inflation. All right, so we start by listing our A, P, I, and N. So the accumulated amount, the end amount, now this is where that came in handy when I was talking about the end amount, is 221,292.32. The starting amount was 140,000, so that's what it started as, and it increased to the 221,000. The number of years it took to increase was 6, and we want to calculate our I. All right, so we have A equals P, open brackets, 1 plus I raised to the power of n, because we're using compound interest. So now we simply substitute. 221,292.32 is equal to the starting amount, which is 140,000, into 1 plus I is what I'm looking for, raised to the power of 6. So we're going to start by getting rid of our P value, or this 140,000. We can't start by getting rid of our exponent of 6. If I'm solving an equation, I am going to be working with BEDMAS. All right, now in BEDMAS, you can see that the E for exponents and the B for bracket are the first two things that I'm going to do. However, when I'm isolating a variable or I'm changing the subject of the formula, I am going to swap this whole thing around, and instead of BEDMAS, I'm going to do SAM DEP. As in, the bracket and the exponent go from being the first thing I do when I solve an equation to the last thing I do when I'm isolating a different variable or I'm changing the subject of the formula. So that's why I'm going to start by dividing by the 140,000 instead of sixth rooting everything. So when I divide by 140,000, then the 140,000s cancel. Now I'm just going to put my 1 plus I raised to the power of 6, that was on the right hand side, I'm just going to put it on the left hand side, is equal to, when I say 221,292.32 divided by 140,000 on my calculator, I get 1.52615391. All right, don't round off until the end. Don't round off until your final answer. All right, now I am going to sixth root everything because I want to get rid of the exponent of 6. So remember, if you're trying to get rid of an exponent of 2 because something's squared, you square root. If you're trying to get rid of a 3, you cube root. So if you're trying to get rid of an exponent of 6, you're going to sixth root. So we're going to sixth root both sides, and we're going to be left with 1 plus I is equal to the sixth root of that, which you would just have left on your calculator, is 1.073. All right, now to isolate the I, I'm going to subtract 1 from both sides. So therefore, I is equal to, now I'm going to round to 4 decimal places. And when I subtract, I get 0.0730. But that is the I value, and I'm looking for the interest rate. So that means that we therefore need to multiply both sides by 100. So therefore, the interest rate is equal to 7.3%. A company bought machinery costing 80,000 Rand. Using the reducing balance method, the machinery had a book value of 20,000 Rand after the 5 years. Calculate the rate of depreciation. All right, so we have A, P, I, and N. So the company bought the machinery for 80,000, so that's what they started with. The machinery started, this is a depreciation question, which means that the machinery is going to depreciate, lessen in value. So the book value at the end of the period is 20,000 Rand, so it's depreciated. It depreciated over 5 years, and they want to know what is the rate of depreciation. All right, so we're going to use our depreciation formula, reducing balance. It says that it's the reducing balance there. So that means that A is equal to P into 1 minus I raised to the power of N. So the end amount is 20,000. It started, they bought it at 80,000. 1 minus I is what I'm trying to calculate, raised to the power of N. N is 5 years. All right, remember, we're not going to start by fifth rooting anything. We are going to start by getting rid of this 80,000. So to get rid of the 80,000, I'm going to divide by the 80,000. What I do to the one side, I do to the other side. So I'm going to divide both sides by the 80,000. So now I'll have 1 minus I raised to the power of 5 is equal to 20,000 divided by 80,000 becomes 0.25. So now I want to get rid of that exponent of 5. So in order to get rid of an exponent of 5, I'm going to fifth root both sides. When I fifth root it, I'm left with 1 minus I is equal to the fifth root of 0.25 is 0.7578582.833. Now what I'm going to do is I'm going to subtract 1 from both sides so that I can isolate my I. So I have negative I equal to, but because even though it's going to be negative, I am going to change it to be positive just now. But because it's negative, because it's the I value, I'm going to round to 4 decimal places just to basically save my sanity. So when I subtract the 1, I'm left with negative 0.2421. All right, so that means that to make it positive, I'm going to divide both sides by negative 1. So I is equal to 0.2421. But I don't want I want the interest rate. And in order to get the interest rate, I'm going to multiply both sides by 100. So therefore, the interest rate or the rate of depreciation is equal to 24.21%. Up until now, we have invested money or we've borrowed money, and that money has been invested or borrowed for a fixed period of time at a fixed interest rate. Timelines come in when there are changes that are happening. So either money is being invested or withdrawn during the period, or the interest rate is maybe changing during the period, and that's when a timeline comes in handy. Now the timeline, you need to represent your years on your timeline, okay? So what I do is I work with sticks, all right? So I take my timeline and I break it into my little sticks. Now those sticks is something happening. So either money is being withdrawn or money is being deposited or the interest rate is changing. So each little stick represents a time period. All right, so we start at T0 or term 0, then we go T1, T2, T3, etc. And each T is a year. Now remember, your years can be broken up as in if I had half a year, I could have term 0.5, T 0.5. Tebogo made an initial deposit of 15,000 Rand into an account. So 15,000 Rand initial deposit, that's term 0, that's my first little stick. That paid interest at 9.6% per annum compounded quarterly. 6 months later, so 6 months, half a year later, so we have our second stick, she withdrew 5,000 Rand from the account. 2 years after the initial deposit, so now I'm on stick number 3, she deposited another 3,500 Rand into this account. How much does she have in the account 3 years after her initial deposit? So I have 4 sticks in total. So now what I'm going to do is I'm going to simply draw my number line with 1, 2, 3, 4 sticks. So I have term 0, so that's where we started, term 0. Then 6 months later, all right, so 6 months later is term 0.5 or term a half. 2 years after the initial deposit. Now there are 2 ways that this could be asked, and you have to read it very carefully because it says 2 years after the initial deposit was made. Now 2 years after the initial deposit was on term 0. It was at the beginning of the deposit. So that means that 2 years after the initial deposit is term 2. If it had, however, said 2 years later, all right, then 2 years later would be 2 years after the most recent change that has happened to your timeline, and that was 6 months or half a year, 0.5, which means that 2 years later would have been term 2.5, but it didn't say 2 years later, it said 2 years after the initial deposit. Then it says how much does she have in the account 3 years after her initial deposit? Again, not 3 years later, because 3 years later would be 3 years after whatever you've just put down, and what you've just put down is term 2. So 3 years later would be term 5. But it's not 3 years later, it's 3 years after the initial deposit, so that is term 3. All right, now if we're going to fill this in, 15,000 Rand was deposited, so I need to put my 15,000 Rand at my term 0 at an interest rate of 9.6% per annum compounded quarterly. I'm going to do that in a minute. I'm going to do the interest, but we can see that the interest doesn't change. What does change is the amount invested or withdrawn. All right, it says 6 months later, she withdrew 5,000 Rand from the account. So withdrawing 5,000 will be a minus 5,000. 2 years after the initial deposit, she deposited another 3,500. So if withdraw is a minus, deposit is a plus. So it's plus the 3,500 Rand that she's depositing. And it says how much does she have in the account at the end of the 3 years. All right, so we start our timeline by filling in our time periods. Once we've done that, we're going to put in the amount of money that is being invested or withdrawn throughout the time period. After that, we're going to go into our interest rates, and we're going to write our interest rates out, and then we're going to finish our timeline with our end value. So this interest is 9.6% compounded quarterly. All right. So the I value remains constant for the duration of this investment. So the I value is going to be the interest, which is 9.6%, but that's the interest rate. So the I value is 9.6 divided by 100. So that means that it's 0.096. So that would be the I value. However, this interest is compounded quarterly. Remember, if it's compounded quarterly, divide it by 4. If it's compounded monthly, divide it by 12. If it's compounded daily, divide it by 365. Remember, when your compounding period changes, you're going to divide your I value and multiply your N value by the same value. What do I mean? So if it's compounded quarterly, I will be divided by 4, N will be times 4. If it's compounded monthly, I will be divided by 12, N will be multiplied by 12. If it's compounded daily, I would be divided by 365, N would be times by 365. All right, so this is compounded quarterly, which means that I'm going to divide the I by 4 because that's what the quarterly is. Now I'm going to finish my diagram with my N values, and that's just between here. So N is equal to, what is N between 0 and 0.5? It's 0.5. But I was divided by 4, which means that N must be times by 4. The next one, how many N's are there between 0.5 and 2? Well, that's 1.5. But I was divided by 4, so N needs to be multiplied with 4. And then over here, how many N's are between 2 and 3? There's 1 N between 2 and 3, but I was divided by 4, which means that N must be multiplied by 4. And now what I've done is I've created everything that needs to go into each and every sum so that we can just carry from one answer to the next answer to the next answer. So my first stick or my first sum is going to be this over here, this 0.5. And what goes with it? Everything that was before the 0.5. So there you can see I have my N value, I have everything that I need. All right, this is compounded. So I'm going to have 3 different sums. So I'm going to use, in my diagram, I'm coloring them pink, blue, and yellow. Okay? And everything that goes with the pink, everything that goes with the blue, everything that goes with the yellow, which means that we're going to have 3 calculations in total. So these calculations are going to be the end of term 0.5, the end of term 2, and then the end of term 3. All right, so for the end of term 0.5, it's compound interest. So A is equal to P, open bracket, 1 plus I raised to the power of N. But for the pink one, 5,000 Rand is being withdrawn. Now I don't want to withdraw it in the next step and then it just magically appears. So I put it in the formula step and then it's there the whole time. All right, so A is equal to how much was invested? 15,000 Rand into 1 plus the interest is right there, 0.096, but it's divided by 4. Raised to the power of, my n value is there, 0.5, but it's multiplied by 4. And don't forget to subtract your 5,000, and this just saves you having to do multiple steps. So therefore, my A value becomes 10,728 Rand and 64 cents. Now, this A value becomes my P value. So the amount that's accumulated in this previous step is now my starting point for my next step. So it's my P value. So now I'm going to have, I've just calculated the end of term 0.5. So now I'm going to do the end of my second stick, which is the end of term 2. So the end of term 2, A is equal to P, open brackets, 1 plus I raised to the power of N. But what's happening at the end of term 2? 3,500 Rand is being deposited. So I put it in my formula step so that it doesn't just magically appear. Now I have this A value over here from my previous step is now going to become my P value. So A is equal to 10,728.64 into 1 plus, the interest is there, it remains constant for this question, 0.096, but it's compounded quarterly, so I divide it by 4, raised to the power of 1.5 times 4 because I put my n value onto my diagram, and don't forget to carry down your plus 3,500. So therefore, A is equal to, when I type all of that into my calculator, I'm going to get an answer of 15,869.27977. This A value that I've now just created over here is now going to be my new P. So now I'm going to do my final calculation, which is the final term, which is term 3. Now, at term 3, you can see on the diagram, nothing is being added, nothing is being withdrawn, which means that I'm just going to finish it up using my P value. So, A is equal to P into 1 plus I raised to the power of N. So now over here, you can see there's nothing being added or withdrawn. So now A is equal to, I'm going to use my previous P value, which is 15,869.27977 into 1 plus, the interest stays the same, 0.096. It's compounded quarterly, so I'm going to divide it by 4. The N, or the time period, is 1 year, but it's compounded quarterly, so it's times by 4. So therefore, A is equal to, remember your units, and it comes to 17,448.46. When I'm reading a question like this, I'm just going to scan and I see the word changed. So something is changing, which means I'm going to have a timeline. So for my timeline, I'm going to count my sticks. Remember, the sticks are just something that's happening, something that's changing. So Sipho invested 30,000 Rand for 6 years. The investment earned interest at 12% per annum, compounded monthly for the first 2 years. Okay, so I have nothing, and then 2 years is when a change happens. Thereafter, the interest rate changed to 10.8% per annum, compounded semi-annually for the rest of the period. Calculate the value of the investment at the end of 6 years if no other transactions were made on the account. So I'm going to have 3 little sticks. So I'm going to start by drawing my timeline, and I'm going to have 1, 2, 3 little sticks. My stick starts at term 0. At term 0, 30,000 Rand is being invested. All right. 2 years, it's compounded monthly. The interest rate is compounded monthly for the first 2 years. So something happens at term 2, the interest rate changes. And it says how much money, or calculate the value of the investment at the end of 6 years. So that's term 6. So if we look at this question, we can see that no extra money is being withdrawn or deposited throughout this 6-year period. What is happening, however, is the interest rate is changing throughout the period. So the interest rate changes after 2 years. So that means for the first 2 years it's something, and for the remaining period it's something else. So we can just list that onto our diagram. So for the first 2 years it's something, and for the remaining period it's something else. And we want to know how much money is in the investment at the end of the period. So the interest starts at 12% per annum, compounded monthly. All right, so firstly, I'm going to say, what is 12% as an I value? 12% as an I value is 0.12, but it's compounded monthly, which means that I'm going to divide it by 12. Then the interest rate changes to 10.8% per annum, compounded semi-annually for the rest of the period. So I would equal, if I had an interest rate of 10.8%, that's an I value of 0.108. right? Because the I values are divided by 100, but it's compounded semi-annually. So semi-annually, semi is 2, so I'm going to divide it by 2. Now I'm just going to quickly finish by doing my N value. So how many N's are there between 0 and 2? N is equal to 2. But it's compounded monthly, which means that I divided I by 12, which means I need to times N by 12. And then how many N's are there between 2 and 6? There are 4 N's between 2 and 6, but that was compounded semi-annually, so I divided the I by 2, which means that I need to multiply the N by 2. So now I'm going to have 2 calculations. So I'm going to have my end of term 2 calculation, which is going to have everything that's green in my picture. And then I'm going to have my end of term 6 calculation, which is going to be everything that's pink. Remember, there's no money being invested or withdrawn during the period. So now I'm going to have 2 calculations. I'm going to have the end of term 2 and the end of term 6. So I'm going to start with the end of term 2. Remember, I'm not depositing or withdrawing anything, so nothing's being added or subtracted. So A is equal to P, open brackets, 1 plus I raised to the power of N. So A is equal to, what is being deposited? 30,000 Rand is being deposited into 1 plus, the interest is 12%, but it's compounded monthly. So 0.12 compounded monthly divided by 12 raised to the power of N would be 2 because it's 2 years, but it's compounded monthly, so I'm going to times it by 12. So therefore, A is equal to 38,092.03946. Now this A value becomes my new P value, so I'm going to use that in my last calculation. So I'm going to have the end of term 6. And the end of term 6, the interest rate changes, but nothing is being deposited or withdrawn. So A is equal to P, open brackets, 1 plus I raised to the power of N. So A is equal to, I take my A value, which becomes my P value, 38,092.03946 into 1 plus the interest now is 0.108. It's compounded semi-annually, so I'm going to divide it by 2, and that's going to be raised to the power of 4 times 2. So therefore, the amount left in the account at the end of 6 years is 58,017 Rand and 51 cents. I hope that this has helped you. I hope that you've taken down notes. I hope that you've written out all your formulas, that you have written out what each letter stands for, and that you're studying that. Remember, the more you do, the better you'll be.